can share with you guys so that if I'm not here,
That's
you can
probably
do it.
good from a hit by a bus standpoint. Please don't get
Well,
hit by a bus.
Patrick has, I mean, lots of people have it. It's not like I'm the only one in the world. Okay, we're ready to start. Go ahead, Praveen.
Okay. Uh, yeah, so today I mostly wanted to discuss about like the KEP and like what's in scope for 136 and also talk about like some of the open questions like that has come up during the KEP review. Um, so yeah, let me also add a link to the KEP on chat. Yeah, so I hope my screen is visible. Um, so on the API side, like I think we've made some changes like compared to what we've been like discussing so far. So basically earlier we had this device class API, like in device class we had this field which indicated like if this device class represents native resource or not. And in the device API, we had all of the native resource mapping, which basically included like what is the accounting policy and like how we want to account from a given like resource slice and claim and so on. So one main drawback that we had with this approach was like since native resource is something that is since slice is something that is created by the driver. Once we set this accounting policy in the device API in the resource slice, there is no way for a user to basically pick what policy they want. So this is okay if we are thinking of like auxiliary devices like GPU, and it adds some additional like native resource capacity that it wants like in the resource slice. But for CPU and like memory driver like use cases, it kind of does not allow a user to pick different like behavior based on the use case. So basically what I have I think I also discussed this with John, like what I've added now is like in the device class API, along with having a field which indicates it's a native resource, I've also added this like native resource policy as a part of device class, and it continues to like the policy itself like continues to be the same as like what used to be in the device API. So along with the device class, we also have the native resource mapping, like basically also have the accounting policy in the device API. So now we have accounting policy in two places, and it's optional like on the like if the use case wants to set it in the device API, we can do that. And if the use case wants to set it in the device class API, that is also possible. But this also comes with like some precedence rules. Like basically, if it's set in both the places, whatever is set in the device has higher priority, and like within the scheduler we kind of look at both the places and pick decide at that point on what exact accounting policy to pick. So as I was saying, this enables like admin defined policy, like where we can for CPU memory driver we can have like different accounting policies in different classes, and a user picks a device class based on the use case. And we have a driver defined policy for auxiliary device use cases. So yeah, this is the main change that I've added on the API side. Like any thoughts or questions around this?
Just maybe to make it a little more concrete, you can imagine, right? Like as a user, I'm running or as an administrator, I'm running the CPU driver, and I want to make those CPUs um, easy to access for people who want to create exclusive CPUs. So exclusive meaning CPUs that are pinned and everybody else is excluded from using them, right? Dedicated CPUs. So I can actually create with this, I can create a device class called dedicated CPU, and I can create another device class just called, CPU. And so I can, if I want dedicated ones, I use the dedicated device class. If I don't need dedicated ones, but say I want them aligned with my NIC, I can use DRA to access CPU that may be not dedicated, but is at least in the same NUMA node as my PCI switch as my NIC, something like that, right? So if we didn't do this, then it would be the administrator at the time they deploy the driver that decides for a node how those CPUs are accessed when using DRA, which is not ideal in those cases.
Yeah. So okay, I think that's like the main change on the API side. The other kind of simplification that we did for the scope of alpha is like initially we had proposed uh, like four different policies, like basically override, add per claim, add per reference, consume from, which was enabling a lot more use cases. But for initial alpha, I think like we uh, decided to narrow that down to like only two policies. One is basically where we specify if we have a resource claim for native resources that adds to whatever is already available in the container spec. And there are two different variants of that. Like one is add per claim, which means that like for every claim, like if the value within the claim is accounted for only once. And for add per reference, this is like for the value in the claim is accounted every time the claim is referenced. So the main use cases for this is like for auxiliary devices, we can start off with like add per reference, where a GPU specifies the additional CPU and memory requests. And basically every time the GPU is shared, those additional requests gets added to the node requested, like per reference. Add per claim is mostly for CPU memory driver use cases where we are reserving like exclusive CPUs through a resource claim, and we want the same exclusive CPUs to be shared across like multiple containers. Then we can have this like add per claim and basically do that. So the reason for like not doing this override or max and consume from was it gets too complicated when we have like multiple containers sharing the claim, or even like within the same container if we have like multiple claims which all have like override policy or consume from. It gets complicated on the accounting side and even on the enforcement side to figure out like how do we want to combine all of these requests across different claims and also shared claims. So basically yeah to simplify or reduce the scope for alpha, we mainly decided to focus on like two additive policies for now, while like these the other non-additive policies, like I have listed them under future considerations. So yeah, that's another change on the API side for alpha. Yeah, I can pause here if there are questions.
Yeah, and just to be clear, like we believe there's use cases for those, but we want to build them, but we both for our scope management, but even more so for SIG scheduling, which is kind of completely slammed. I don't want something really complex that's going to take them hours to understand, and like they don't have the time for it. So I think that in the sort of art of the possible, like we have to cut some scope.
Yeah.
Is that okay?
Release. For next release.
Yeah.
Yeah, I'm curious, like whenever we postpone something like that, making out the scope, I was, Praveen, you said that we are not sure how it will all work with shared claims and like how we combine claims. Do we know that it will work? Like, do you want to validate that it will work and have a clear plan of actions before we getting out of scope and saying like it will be built in future, or it's reasonably straightforward? Like
I think it's reasonably understood. There's some debate about. So the way that it was written up has a better UX in a lot of ways, but is a little bit confusing in the way that we sort of, especially with consumes from, we sort of flip the meaning of some of the APIs, the semantics of some of the APIs in a way that like makes a lot less configuration the user has to write, but is a little bit hard to understand. So there's some debate about that, whether that's which is the right way to go. And then we know how to do the accounting on the consumes from. We know how to do we have ideas about how to do the accounting on the override or add, but there's some debate about, or rather override or max, but there's some debate about which one we should do. So it's not as much that we don't have a clear path on the accounting side. Now, Praveen might be able to say on the enforcement side whether there's additional complications.
Yeah, I think like on both the side, it's better understood on the accounting side. The main concerns there was like, how do we make all of this like more understandable from the user point of view? Like basically, if they said something in the pod spec, if they also have something in the claim and like combine multiple claims and shared claims, like how can we make it like more understandable on the user side? I think it is possible, but I think it might need like some more thought behind like how this all fits in together. On the enforcement side, I don't think we have spent like too much time on that at this point. Like maybe like for consume from, it is relatively easier, I think. But for override and max, I think there needs to be like more discussion on how we want to do the enforcement.
I think
Don or Shah?
I just want to add to the same answer. So we know how to technically implement both of those policies, and even with enforcement, we have some ideas. But what the main problem is like we cannot describe what to the user or describe it good in the documentation. And plus, we also
we have a hard time understanding it ourselves. So how is the user going to understand it?
Yes. So the people who are deep in it have understanding, even the difficult one, but we still have it. For end users and for SIG scheduling right now, we will be having a hard time to explain it. And algorithmically, it's a bit more complex compared to the additive. So right now, let's do the additive first and more complex as a next iteration.
Yeah, Matt, I guess I'm the one of the people push the back, try to narrow down the scope. And for the first alpha, yeah, just I think Sasa summarized a lot of those concerns what I raised, because when Praveen and I doing this one-on-one review together, I understand all the use cases, but it's just really hard for me to connect all the dots on the user perspective, how to user to using those kind of family. Even sometimes, because if I remember correctly, there's the one of the use cases I described, there's the two different type of the user, who of the submit of those workload and who it is really in charge of those kind of underneath infrastructure. So there's the two people involved, at least the two roles involved there, and how to do those kind of things consume. So that's kind of the things I think is a lot of question. Another thing it is totally different use cases, and what they try to, if I remember correctly, I even try to narrow down one single use cases here, policy to support for alpha. But what I believe it is, we cover a lot of use cases already, and those is the separate use cases independently, right? So I want this is alpha, and at least we got we can roll out, iterate faster, and with the narrow down scope, then we can got the user inputs, right? Because this one, at least I can picture how user configure, because it is kind of independent. They can know, okay, for my workload when I deploy, and how much I want additional added to achieve my goal. So, but the other two is unclear to me. And so that's why we want to narrow down the scope, and we can iterate faster. And I also open to say this is the alpha 1. If we really need those kind of things, we can have alpha 2, or we just want to graduate this quicker. Anything, I just want to say that if you make that is the API, later you change it much harder. And so now we have like the more time to think through all those end-to-end use cases, how we are going to manage the, it's not limited on the node level, right? So that's like how to accounting, how to those, we know that one because a lot of the in the past, but really from user perspective is unclear for us. Yeah.
Thanks, John. So, just in the future consideration section, I've kind of listed these additional policies and their use cases and how accounting should work. Like it gives like a high level overview, at least on the scheduler side, how things work. But yeah, this needs like a lot more thought, I guess. Dominic?
Yeah, I wanted to mainly to say hi. I'm like joined to listen like what you are discussing, and yeah, what John said, the simpler we have the proposal, the better. So yeah, so I will like go through that.
Dominic, are you going to be our approver from SIG scheduling?
Excuse me?
Are you going to be our approver from SIG scheduling for this CAP?
Yeah, very likely.
Okay, so if you want to set up you, me, Praveen, and if anybody else wants to join, we can go through it in detail. It might be faster than you. That way you can ask questions and stuff.
Sure.
Let us know when. Yeah.
Sure. Like the first thing that I read, because I just started, is that we will once a pod has a resource claim, then we enter this special logic for accounting, right?
Yeah, like on the Cube scheduler side, like it is kind of similar to how we manage extended resources, where like we have this delegation mechanism between node resources and dynamic resources plugin. It kind of borrows from the same approach, like in this case with native resource claims. Dynamic resources plugin would be responsible for doing the entire like node resource fit check. So that is the high level approach that we are trying to follow here.
And the resource claims will be created by scheduler?
No. In this case, we would not need any placeholder resource claims. So if the scheduler, if it detects that like if a pod has native claims, it knows from the device class if it does, and it uses that to delegate between node resources and dynamic resources plugin.
Okay, so we are not addressing the case that someone is specifying just native resource CPU spec in spec, and it can I don't know.
We're not translating the container spec and pod spec resource requests into resource claims. We're like we do for extended resources. So it's different. It's not the same as what we're doing for extended resources. I mean, when we originally did the extended resource things, I thought we might go that way with this, but we've moved away from it. The strategy we're using here is that for any given device, you can attach additional native resources to be allocated whenever the device is, in this case, allocated or referenced. So the use cases are things like, and of course, that device could be nothing other than CPU, right? So that could be, the degenerate case for the CPU driver is that the device is nothing other than the CPUs. So it's just the attachments. So but if you think about like Sasha has maybe you have an FPGA, and whenever a process wants to access that, it needs a 1 gig buffer, right? And so every time you even though the FPGA is allocated once, right, and maybe initialized with some functions or something, then you have 20 containers that are going to reference that FPGA. Each one of those containers needs a bit of overhead, And so this allows us to account for that kind of overhead in those use cases.
Okay.
So it's a different approach than it uses some of the same idea of like you have to coordinate between these two plugins, but in a similar way, but it's not the generation of resource claims type of thing.
So Dominic, think about it. What this claim is actually telling how big or what is the actual size of a container or a pod will be. And it just hides the logic how it's calculated. So the end result is like, can we fit it into the node or not?
Mm-hmm. Okay.
And one additional thing that we would need to do here is like we need to also update the node info so that like in the future a pod without resource claim has the right visibility of what is available. So we need some changes on the pre-bind, like in the bind stage, and also some ways to like hold all the state in the node info struct. And basically we use the pod status to communicate like what decision was made in the dynamic resources plugin to the bind stage, and like consider that for accounting and update the node info. So that we did not have to do in the case of extended resources, because all of the management was done within the dynamic resources plugin. Basically what devices available, used, and so on. But in this case, since we have like to support existing use cases, we also need this step in the framework, like during the bind stage.
Okay. So I'm thinking how it's gonna interact with the changes that we are currently doing. So briefly, I can describe you that we are creating, defining a new workload scheduling cycle or a phase in which we will schedule basically very similar like pod by pod, but within this within a pod group, we will just sync cluster state only once for all the pods. So as if all those pods are scheduled in a single cycle. Currently, the basic implementation does not do anything fancy rather than trying to schedule every pod in the pod group. But there is also topology or scheduling cap, which introduces the concept of trying to schedule few different schedule using few different topology options, so that we will like go back and forth trying to schedule something in memory only. So it will not go to binding anywhere, just we simulate in memory that scheduling of the whole pod group, so scheduling of few pods. I have to read more about this binding stage, but what is important is that in memory resource calculation needs to be correct already.
Right.
Yeah,
And
to-
so
to-
you
to-
wait for the binding stage to have the. I think what Praveen is saying, and correct me if I'm wrong here, Praveen. Like this is about the cache update because we're doing
Yeah.
pod by pod scheduling, and we want to make sure the next pod that comes along has the correct. Internally in our own process, as we're in the middle of it, we know exactly what's going on. So similarly, in the middle of the workload scheduling, I think you'll know exactly what's going on. This is sort of just the commit of it, so that the next iteration has the right stuff.
Next iteration, you mean?
Next pod,
Next pod that is getting scheduled.
workload, right? Whatever. Next.
Okay, but the binding is asynchronous, right? So the next pod. Okay, so you are saying what you are doing is that the in-memory representation is ready for the next pod.
Yeah.
So anyway, yeah, we can go over more. I think.
Yeah, I can set up sometime later this week with Dominic and whoever else is interested, and we can go over the KEP in like more detail.
Yes, please. We can. Maybe we even have 6 scheduling. Let me check. No, we don't have this week.
Praveen, did you have any more you wanted to talk about? Otherwise, I think Sergey, did you want to talk a little bit about what you're thinking about and
Yep.
Yeah.
My turn.
Sergey, you can go. I had a couple of other questions, but that can be taken
Yeah,
offline.
fine, if you
If we
want.
have time, we can come
I
back later.
probably will drop in the meantime. So if you have any other question to me, then
I think the rest of the questions I had was around like the node enforcement. So I think this is everything I had for the scheduler side of things.
okay, thank you.
Yeah. Okay. Do you want me to go? Okay. So yeah, I linked a document in a agenda. I threw together a few sentences from different other documents I had, and the things that I discussed before. So the problem I wanted to solve is we historically have this desire to sandbox system daemon sets on certain environments. Like on some environments, it doesn't make sense. On some environments, we want to share and overcommit as much as possible. So system daemon set run alongside the user workload, and it's all desired and expected. But on some environments like HPC recently and more and more, increasingly more in AIML, people want to sandbox all the system daemon sets. So they kind of not standing in the way. And by sandboxing, I mean separate CPUs as a minimum, but there is also conversations of memory limit for all the sandboxes together, all the system daemon sets together. So that led me to thinking like how currently implemented, and like I found some NRI plugins, Cryo has some implementation, but also like what can we do to make it such that it will be known by DRA and all the resource management that we have in kubelet. And because of that, I thought like maybe it needs to be a native Kubernetes API that will explain what the sandbox is. And if you create this for system resources, I thought the logical next step is to make it for other type of resources as well. So I get to the proposal called node partitions that allows you to define subsets of node, and then pods will be able to target those partitions. So if you schedule a pod, you can specify which partition targets, and then it will be scheduled on the same on the targeted partition, and scheduler will treat every partition as a subset of resources of a node. So ultimately, almost like a node. And then we can apply very cool things like we can get we can get overall memory limit for partition. We can reserve CPU sets. So HPC workloads are not limited to be guaranteed execution with integer number of CPUs. Now you can mix and match, and they still will be scheduled on this subset of CPUs you allocated for HPC, and nothing else will interfere with that. So bunch of scenarios. There are also scenarios that can be enabled by this API, but then this API and DRA consume 4 that was discussed here are kind of intercepting, at least on like HPC workloads when you want to allocate this claim, and then you consume out of this claim, and this claim is consumes from a node, so it's it getting a resource from a overall node. So it's pretty much the same concept. The problem, though, for me is like even if you put that back in the scope, like it was reserved for or like consumed from, and then we implement it, I don't think we will be able to use this DRA thing to satisfy my very first scenario and very basic scenario to sandbox system daemon sets. First, it wouldn't satisfy because there will be a bunch of race conditions that we need to account for, and those race conditions are will not be really easy to overcome. And second problem is that we don't like as designed right now, and I don't know like how and when it will change. All the C group hierarchies are currently controlled by both kubelet and containerd or like container runtime. So if you want to split partitions into separate hierarchies like of C groups, then we will need to do some magic in kubelet and some maybe back communication. So I think it may be easier just to implement it as a kubelet and Kubernetes native pattern, and it will satisfy majority of scenarios working with topology managers, resource managers, as long as DRA in future, and DRA may be used for advanced scenarios. So that's why I brought it here to discuss how much interest people have for native resources, native support for this concept, and how much you want to continue doing it through DRA. And I see already so many hands. I'm not sure who was first.
Sasha's first.
Yeah, so to reply part by part. So for HPC kind of workloads, it's exactly one of the reasons why I was initially proposing with consume from. So like allocate some of resources and make sure what we're pods, what is going to use it will be tied to this sub portion, and we can dynamically resize it and pre-allocate it. So we like the rest of the node will not consume this pre-allocated piece of resources. So we can do like normal enforcement, we can do normal accounting. It's all kind of good. And Sergey, you are correct. What like it doesn't fit into a scenario what you are having about splitting the system resources or system daemons and so on. The problem is what is supposed to be considered by system. So in our CPU, I mean Intel vendor CPU management project, we have this kind of functionality. So we can pre-allocate system reserved portion of the resources, which needs to be set exactly to the same values for kubelet to do the accounting. And then based on the normal criteria, like the namespacing or maybe special annotations, we can declare what particular container or particular pod is considered to be a system. So it will be isolated into this portion of the resources. Something like that theoretically supposed to be implemented in the kubelet side. So like we have this concept of system reserved or resources. The only thing what the CPU manager and the rest of the manager and memory manager were not respecting it. So like creating a special pool inside the CPU manager for the same, like to do the same thing, it's clearly doable. What we are doing with DRA here probably is not the good fit. I mean, I would consider those as two separate things. So system partition and managing the system, it's one thing, and all this kind of like peer pods for confidential computing, or like what we have, like pre-allocation for specific hardware, those can fit into the concept of consume from.
Sergey, did you want to respond to that, or shall I?
That's exactly why I brought it here. System resources may not fit into this DRA concept. And moreover, I feel like many non-advanced scenarios may be easily satisfied by these partitions. Like, let's say we implement the partitions for system. If we, instead of calling it a system reserved and like building the whole infrastructure around reserved, we just say partition name, and then partition name, it's like system partition maybe either applicable for the whole node, so then system workloads will simply schedule the whole node, or the same partition can be applied to subset of node. In any case, we will get into like proper functioning system daemon sets, and it's all working. But then like system daemon sets become not the only partition. You have other partitions, and those partitions nicely working with CPU manager, nicely working with all other concepts. And DRA plugins may know about partitions as well. So my point bringing it here is since if we will think that system daemon set sandboxing is a very important scenario, you want to implement it, and we implement it as a partition, then we may have this concept of partition applicable to most scenarios. And then I question like how can we rationalize this between DRA and partitions?
The biggest difference, Sergey, what I was describing for system and the full-blown partition for the system is like the total accounting and complexity implementation on the scheduler side. So, like if we implement the simple like system versus anything else on the node, when like whatever we have in the node status right now, it's enough for us. So we have total amount of resources, we have like allocatable amount of resources. What scheduler knows what something is reserved for the system. But if we start to implement the like dozens of different partitions on the node, it means that all of those partitions we need to expose to the scheduler. So like we will have this dozens of node status objects for each node.
Yeah, but I want to expose it to scheduler because scheduler will need to know that if system daemon set doesn't fit in this partition and it's expected, then like it's waiting, like it doesn't try to impose this system daemon set on a node that it doesn't fit it. So it will be visible. So I want scheduler support for this as well.
Right, but the point is it's easy to support it in the scheduler if it's one fenced off area, but if it's multiple fenced off areas, then we need essentially all the tracking we do for a node right now, we need to start doing on a per partition basis, which may be challenging.
Yeah, that was my point. Yes.
Yeah. One other thought I had was you needed an API to describe these partitions. And, you could do it, I guess, very statically, like these specific CPUs or something. But like we have the DRA is an API for describing kind of subsets of nodes, right? This claim can have multiple requests. Each request can be for a CPU, for some memory, for some other devices, and then we can put constraints on how to align them. So if we wanted to avoid the race conditions, we could think about, people probably will hate this. We can think about like we have static pods, we can have static resource claims. And so essentially we have a file on the node that describes using the resource claim API what these different partitions are, but then they get exposed to the scheduler in exactly the same way as if they were a user created one with a consumes from, right? So in a sense, like we have, I don't know how the user, like we'll have to think about what the API spec would look like there since the resource claim is created over here, in the kubelet, but there's no race condition anymore because the driver can, on startup, well, really it's the kubelet on startup, and then it goes across multiple drivers. It can create these resource claims and fence off the partitions, publish that resource claim up to the API server where it can be utilized by pods. But that's the part that I think I don't understand how it would work yet. But curious what people think about that approach. It's kind of using the machinery that we're defining already in this group to with an addition that avoids the race conditions you're concerned about.
Static pod also have the race condition. But of course, if we fake that a static pod always exists, then that's become the configuration. That's become to similar like what the partition is, right? But if you run as the normal static pod, they could be even do nothing, still could be whatever region, and crash, and then next Kubernetes reports won't have that static pod. We run into those static pod problem all the time. But you can fake that static pod. But when you fake it, then why don't you just reserve from configuration, treat as the partition then?
Yeah, and just answering, John, to your questions that we need to teach scheduler about it. Like, I don't want to teach scheduler about CPU, like specific CPUs in this proposal. So this proposal will just tell kubelet configuration, what CPUs are used for which partition. And then DRA, if it wants, it can read the same configuration. So
No, I know the scheduler doesn't have to know about CPUs, but it has to know about partitions. Right? So today in the scheduler, in the node status, right, there's like a bunch of tracking for, what's allocated. So now we have to track it on a per partition basis.
Yeah, that's the proposal. Like just split it into partitions, and not tell scheduler, like DRA will tell scheduler about CPUs, and it will ask from kubelet itself the same configuration.
Yeah, I understand that. It's viable, right? We need to check the six. Dominic left, I guess. Unfortunately, we probably should have kept him for this. Like, I don't know how. And Patrick is here, I think, and he knows the scheduler pretty darn well. Like, I don't know how much. I don't know how reasonable that scope is for that sort of shift from tracking a single node to tracking multiple partitions per node throughout the whole framework. I don't really know.
And plus classification of a pod, like which pod should consume from which partition.
Totally, and also larger side, and also the each node play different role, right? Support different of the type of the workload. So we understand. This is why I want to, like for the HPC workload, of course, I want to reduce the interruption from those system daemons, right? But the fundamental problem it is a lot of the. Do you need that many of the system daemons for a HPC workload, right? So we should make those system daemons, all those daemon sets, a lot of daemon sets, even like invisible. But a lot of other use cases, you need those kind of things that provide additional network policy, additional of the storage support, all those kind of things. So it's really hard to configure those kind of things. And also, but for HPC workload, I do think about we have a lot of things already, like reserve system CPU, it is one start point, but it's not enough. The problem it is mostly not enough. We do reserve resources for system, and we also reserve resources for kube, right? But we don't do the enforcement at the node level. So scheduler knows those kind of things. Of course, the scheduler don't know maybe particularly like CPU index from 0 to what number it is reserved, but they do know the reserved resource. So more it is from the node side how to base on the how to enforce those kind of things. But the one question, open question, it is we don't have workload like this node. We don't have the workload information. If I do know this node or group of the node I created, it is for HPC workload. I could just not just enforce, and also I could do more, right? So like alignment and upfront reserve certain things. So those kind of things we could do at the node level, but just I feel like the partition the node and goes to expose that information to scheduler is dangerous, right? So we already have the scheduling bottleneck today for scalability. And this is why we are looking into the GAN scheduling, all those kind of things. And partition node, simple node to the scheduling part, and divide it into the 3 node kind of like, that's too much. That's overkill for me.
Overkill over some other solution to do sandboxing, or overkill that we don't need sandboxing? I just
other solution, yeah, because I feel like we have a lot of things we could do. We're only missing it is the workload information. But I think we can do some prediction, right? So at least for people who run HPC workload, AI training workload, they know those nodes was for, right? So they even need choosing different after. So then we could get that information and have different type of the configuration at the node level. Instead, the surface everything goes to scheduling. Yeah.
Yeah, Sasha, that's exactly right. Like every scheduler will need to do extra check on partition, and partition probably will be property of a pod. I don't know like how to comment on that. Like I was thinking about a lot about how to do sandboxing of system resources, and I cannot come up with anything simpler than just telling scheduler how much is reserved for system and like start marking system pods as a system. So that probably will be the absolute minimum how you want to like what information you want to give to scheduler?
Well, some of information already available to the scheduler, like how much is reserved. The only thing it's not accounted anywhere right now. And for scheduler, there is no difference. Is it system pod or is it some normal pod? And actually, to do it in automatic way, it's really hard to do because, like, well, we have a kube system namespace that can be considered as a system, but when like bunch of like different like loggers and monitoring systems and so on, they might be deployed in different namespaces. So we need somehow to teach the schedulers what like all of those pods actually should be considered as a system, and that is the bigger challenge. I mean, I wrote in the chat, it can be relatively cheaply implemented right now, but just some drawback about this classification part.
Yeah, not only that, but also like, I mean, if you mean it can be implemented now, you're saying that kubelet will need to change to start tracking special partition, but just don't tell anybody. Yeah, that's maybe the first step.
I think Francesco's been waiting quite a while.
Yeah, Francesca. Yeah.
Hey, hello. So, circling back to the original proposal, Sergey, do you envision potentially infinite, okay, maybe high amount of partitions or few, like system partition, HPC or high priority partition, and everything else? So I'm trying to get a sense of how many partition could we possibly expect, and then I have a follow-up question.
I built it for just system partition, but then if you have a partitions, I thought that it may be useful for most scenarios. And like I hear these telecom scenarios with high performance CPUs and less performance CPUs. And like, yeah, if you have a way to do partitions, why not expand it to other partitions? And I don't envision a lot of them. I envision just like two in typical use case.
The reason why I'm asking about the number is because I see a quite strong use case for the system partition, because this is pretty much an extension, or could be seen an extension of what we have right now with system reserved and every reserved. But so let's say two partition, so system and everything else, it's kind of straightforward to me. And this is why I asked about the number. But having few of them makes it more challenging, because next question would be, okay, if the node has, for example, pressure, from which one should I evict? From which one should I pick my workload to? Okay, you need to go. Sorry. So what do we want to set priority among those? And that would be my last question
The
for
pressure
now.
would only be per which pressure, like each partition is completely fenced off. So you'd actually have to have pressure per partition, not pressure per node anymore, right? So
yeah, it'll be even easier this way.
Okay.
I mean,
Makes sense.
easier, except now we have to have pressure per partition.
But when the problems of priority between the partitions.
Yeah,
Like
yeah.
So all of this is supposed to be reflected in the C group hierarchy.
Was the question? Like, I didn't get the question. What's C group hierarchy?
Well, what I meant is what, like right now we have only one layer of hierarchy. So like we have burstable, guaranteed, and best effort containers. So now if we start splitting the system, so we need to create intermediate layer in the C group hierarchy. So these groups or these partitions will become like the first layer, and inside of it we need to start creating this guaranteed, burstable, best effort structure for the containers.
Yeah, I understand that. We may need to do more detailed design for this. I think it's solvable. I guess my main question here, like we only have 8 minutes left, is how much the system daemon sandboxing scenario is important? And second question is, do we believe that DRA consumed from will get to solve this problem? Or if it wouldn't, can we start designing this and as a cap, as a separate concept built in Kubernetes?
In my opinion, I believe what special treatment for system plus the DRA consume from should satisfy both of those scenarios. But actually, before we go to further, Sergey, I have one critical question. So, like you here demonstrates the HPC kind of workloads, and you wrote here like guaranteed burstable best effort classification inside. So, do you really expect what, like inside these HPC partitions, the Kubernetes still scheduling the workloads, or do you consider the like more the scenario what this HPC partition will be given to another scheduler and node agent to actually orchestrate the HPC workloads on it, because it's like it's two different stories. In the second scenario, when we
DRA will-
delegating it to something else, it might be a lot easier to just say like, hey, kubelet, on this node, with resources has just shrunk it, and like you don't have like all the available, you have only like half of a node available for scheduling Kubernetes workload. The rest is not yours.
I think Kubelet will still, like, you can either use node partition with standard resource management, or you can use partitions with DRA that allocates on top of it. It doesn't really matter. So the good thing about built-in API is that it can work with either, and you're not limited to that. And it satisfies big scenarios, but it also enables to do deeper by implementing advanced node allocation or like resource allocation.
I mean, I guess I'm leaning towards what Sasha said as well, but I think if you want to, like, I think the big question for me is like, this seems like it's going to have massive ripple implications all the way throughout the scheduler and maybe and the kubelet and maybe even the container runtime. Before you go down this path, I would suggest spending more time with SIG scheduling and thinking through all the implications. I think that most likely from a how do we deliver something that covers most of this functionality in a reasonable amount of time, then Sasha's approach of like, let's treat system as special and continue on the path we're already, partially down for the consumes from. I can see value in like what Francesco's saying on, like, I can see there's value in it that might be beyond what we get from that. I suspect that the ripple effects are going to be much bigger than you realize throughout the system. So that would be what I would focus on trying to understand.
So you have a hunch that DRA will eventually solve this problem. Is it?
No, the special functionality around system partition to avoid all those race conditions you talked about, plus DRA, will be a lower risk, lower time to market than node partitions with 80% of the functionality. That's my hunch, but it's worth exploring.
Okay. Is that any other thoughts?
Well, actually, I would like to hear feedback from Marlo. So, like, the scenario, what I try to express. So, like, are you still considering to deploy the HPC workload as Kubernetes pods, or you want to deploy it separately by your own, like, Slurm component?
Both. So we'll be using both. We want to be able to do it as Kubernetes native though, and we've been trying to move our scheduler over with this as an underpinning so that we don't have to do, so that kubelet owns the resources at the end of the day and we're just doing the scheduling. Did that make sense?
Yeah, when for you, same scenario, like consume from theoretically should provide you what you need.
That is the theory, yeah.
Marla, I don't know if you've looked at that other, and we're out of time almost. There's another document
The API one that you sent?
Yeah, using
Yeah.
this to us. So Morton and I are going to try something for TPUs. I think we don't need any changes if we do whole claim allocation externally. So Slurm could actually do its whole thing and use the CPU driver, and we'll add memory to it and whatever, and it could allocate everything without having to kind of program via cell. So I think it could be really useful for you.
Yeah, that's a preference because going through cell for just core enumeration is confusing.
I do have one last question to Sasa. So back to this node partition proposal, when Sergey first mentioned to me, I do remember many years ago, just reminded me, a couple years ago, not many years ago, you mentioned to me, ideally you hope there's a way to group of the inefficient C group together and the efficient C group together, because they are because on a single node, those modern CPU architecture topology, and then serve different type of the workloads. Do you remember those kind of things? And for also workload. So if that's the cases, then I think we maybe have to go through this node partition. But last couple of years, I haven't heard that use cases never came back to me. And so I was wondering, are you still have that thoughts?
I still have it for particular workloads. Well, okay. The question is really complex because it's depending on what kind of CPUs are available on the market. So the scenario when we have a CPU with different types of cores, it's only right now at Intel is a client CPUs. So meaning desktop. Those CPUs sometimes are used in the clusters what is like Edge and IoT. And for them, yes, they have a distinguish between P and E cores, and they want to group some of workloads based on that. So for us, this current proposal about DRA native resources, we can easily model it by different devices with consumable capacity, and this consume from is actually one of the usages what we can do. So we can declare what claim for E-cores, and when all the pods which supposed to be using those energy efficient cores will be pointed to that partition. So for us, it's solvable.
Okay, that's good because I never follow up on those kind of things. I want to see that. Do you have the strong case? Okay, thanks. Yeah.
Signal meeting starting now.
We're over time. I think we better go. Thank you. Bye-bye.
Thank you.